Hi everyone, in this video we are going to discuss about electrical analogies of mechanical rotational system guidelines. The three basic elements, that is moment of inertia, rotational dashpot and the torsional spring in the mechanical rotational system are analogous to resistance, inductance and capacitance of electrical systems. In case of the mechanical rotational system, we are giving an input as a torque which is analogous to either voltage or the current. Therefore, we have two different types of analogies, that is torque voltage analogy. Another one is torque current analogy. Let's discuss about the torque voltage analogy. In this mechanical rotational system, the input is a torque which is equivalent to voltage source in an electrical system. The output is angular velocity. In case of an electrical system, it is current through the elements. Now, the dash part which we are going to represent in terms of the resistor in electrical system, the moment of inertia is nothing but an inductor. The spring is represented in terms of the capacitor. Here angular velocity is denoted by omega. So all the angular displacements, that is theta, we are going to represent in terms of the omega. Let's see the torque current analogy. In case of the mechanical rotational system, the input is a torque which is equivalent to a current source. Output is an angular velocity which is omega. It is equivalent to voltage across the element in an electrical system. Dash part is represented by resistor. A spring is represented by inductor, and the moment of inertia J is represented by the capacitor. We have an input torque which is represented by the current sources. Now we will see what are the different steps we have to follow to get an electrical analogies of mechanical rotational system. First, we have to draw a free body diagram at each node, that is J. Then we have to write the differential equations governing the mechanical rotational system. Replace the displacement, that is an angular displacement, in terms of an angular velocity. Theta is replaced by omega in differential equation. Then we have to draw a torque voltage electrical analogous circuit, and finally a torque current electrical analogous circuit. Let's see the torque voltage electrical analogous circuit. Here, if we see an electrical system, the elements in a series will have the same current. Similarly, in mechanical system, the elements having same angular velocity is said to be in series. The elements having same angular velocity in mechanical system should have an analogous same current in the electrical analogous system. Each node, that is a mass which we will call it as a J, which corresponds to a closed loop in a electrical system. The number of meshes in electrical system is nothing but number of nodes, which is nothing but the moment of inertia. We are going to apply an input torque, and all the elements in the mechanical system is represented in terms of its equivalent electrical analogous circuits. The elements connected between two J's, that is moment of inertia, that is two nodes, is represented as a common element between two meshes in the electrical system. In a short, if we have an input torque which is represented by an voltage source, angular velocity is represented by a current, the mass is represented by an inductor, that is the J is represented by means of the inductor, dash part is represented by resistor, spring is represented by capacitor. We are going to use the Kirchhoff's voltage law to write the mesh. Next we will see the torque current electrical analogous circuit. In electrical system, the elements in parallel will have a same voltage. Likewise, in mechanical system, the elements having same torque are said to be in parallel. The number of nodes is equal to the number of nodes in an electrical system. The number of nodes will be equal to number of nodes, means the number of voltage sources and the system equations will have same as that of the number of angular velocities of the nodes, that is the moment of inertia in a mechanical system. And in case of the mechanical system, we are going to apply the input torque. All the elements associated with the mechanical system should be represented in an equivalent electrical elements. If the element is appearing between two masses, then we will be representing this as a common element between the nodes. In case of the torque current electrical analogous circuit, the torque is represented as a current source, angular velocity is represented as voltage, mass, that is moment of inertia J, which is represented as capacitor, dash part is represented by resistor, spring is represented by inductor. Here we are using the Kirchhoff's current law to write the node equation. These are the references. Thank you.